Hey, welcome back to POE. Today we're going to talk about statics, or statistics, not statics. I don't know where that came from. Statics is more about force. But what's statistics? Statistics is the collection, evaluation, and interpretation of data. Statistics, there's two types of statistics. There's descriptive statistics, which is where it describes the collected data, and there's inferential statistics, which is a generalization and evaluate the population based on sample data. Data. We can categorically or qualitatively have data. Values that possess names or labels, colors of M&Ms, breed of dogs, etc. So this is categorical or qualitative data. We can have numerical or quantitative data. Values that represent a measurable quantity, population numbers of M&Ms, or defective parts. So it appeared to be like if you're talking about the number of people, or if you had you want to know the variety of colors in a classroom, or if you want to know the variety of different types of shoes, or what are the different M&Ms. We're not talking about how many M&Ms, but what are the different types of M&Ms. You could talk about peanut butter, plain M&Ms. There's probably other ones, just different ones during the Christmas time. Down here at the bottom, when we're talking about numerical or qualitative data, this is when we're talking about how many M&Ms come in a box, how many candy bars are in that container, how many Snickers come in that Halloween package. Data collecting, we have random, systematic, stratified, cluster, and convenience. Graphical data representation, we have histograms, which is like a bar graph. All right. We have frequency polygons, that tells us the frequency distribution of a graph. We have a bar chart. So a histogram and a bar chart or a bar graph are not exactly the same. They're similar. Pie charts. It's categorical data graph percentages. So a pie chart's going to give us percentages. Okay, measures of central tendency. The mean, the arithmetic average. It's the sum of all data values divided by the number of data values within the array. So forget about this equation. We know how to find the mean. All right, the mean is we simply add them all up and then divide by the total. All right, it's the arithmetic average. The sum, that's what this S means, is the sum. Those of you with higher level math, you're probably used to seeing a more of an epsilon symbol right there. X are all the values. So here's an example where they take all these values, they add them all up, and because there's 11 of them, they divide by 11 and get a mean of 47.64. That should not be very new to you. Measures of central tendency. It's the median. The median is the one in the middle. All right, it's the one in the middle. So what they do here first is they go from lowest to highest. You could go from highest to lowest. It doesn't matter. Then it says select the data value that splits the data set evenly. So in this case, they got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And 58 is the fifth or sixth number. So there's 5 to the left and there's 5 to the right. So 58 is the middle number. What if we have an even number of numbers? Such, for example, they have here they've got 12 numbers. There's 4 to the left and 4 to the right. Well, what do we do with 58 and 59? We're going to take these two numbers right here. We're going to take these two numbers right here and add them. All right. I just had a pen up here. I don't know what happened to my pen. All right. So they would take 58 plus 59 and then divide by 2. And that's going to obviously turn out to be 58.5. Mode. Mode is the one. I'm not going to spend much time on mode. Mode's really easy. Mode's the one that's the most common. All right, it's the most common. For those of you who are listening to the notes, that's all I'd write right now. Mode is most common. Um, some things they tell you, all right, is it may not exist at all. The mode may not even be one of the values, and that's what I want you to understand. It may not exist at all. That's why I'm moving it around there. It may not be one of the set of the numbers. You can have a modal, bimodal, or multimodal. Meaning if you have two numbers that say they both happen to be 5 and that's the most common number, then it's bimodal. Multimodal means you'd have more than two. Maybe you have four numbers that each happen 3 times, and that 3 times makes them all four of those numbers to be the most common number. Then you have a multimodal. Here's an example of this. In this top one, the mode is 63, so we have just a mode. The next one, we have 63, 59, 63, 59. So 63 and 59 are, it's bimodal. There's two of them. And then the last one, we've got three of them, so it's multimodal. All right, data variation. We can have a range or a standard deviation. A range is just the lowest and the highest, and we subtract those two. Standard deviation we did in IED. We're going to go ahead and review it here again. Here's an example of range. They're going to take the highest number minus the lowest number. The highest number in this case, which is 63, had to move it over there a little bit. The lowest one is 2. 63 minus 2 is 61. That's our range. Here's standard deviation. All right, we did this quite a bit in IED, so we're going to talk about this again. I would get these steps down, get the equation down, because this is something we're going to do quite a bit. Here's an example of doing standard deviation. They've taken this number and they've put them in order. I would advise you to put them in order because this is not a good example of it, but a lot of times I'm going to give you numbers that repeat. So instead of having to do every single problem out individually, like you might have three of them that are 48. So you do it one time and put the same answer down for all three problems. But in the standard deviation, this means take the sum. We have to take this x stands for the values, m is the mean. In this case, n is the number of values. Subtract 1 and divide it. We have the square root. We'll talk more about that in time to come. Hopefully you guys remember the standard deviation from IED, but we'll do a couple problems in class.